Awesome. So, hey, I appreciate the time. For those of you that know me, I always enjoy getting in front of the group. You guys are really dynamic. So I hope everybody goes off mute at some point and asks me some questions, because that's my whole goal, is to interact a little bit more with everybody. Again, I'm going to talk about advances in wireless security. Unlike following Fred and Daryl, who have tons of stuff to show, you really don't show security. It's kind of just there, and I don't have any really cool demos. So just as I said, hopefully we can make this dynamic. So I really don't have anything on the agenda other than let's cover security, which is WPA3. So I've watched over the last day and a half. MAC address randomization has come up. Would love to discuss that. I have a whole section on it. So we can dig into some of the details, and please feel free to bring this up. One of the things I do have, this is my disclaimer. All views made today are by me, the mild-mannered Cisco engineer, and not the current Wi-Fi Alliance security chair or a member of the Wi-Fi Alliance. So again, this is my interpretation, my view of what's going on in the security landscape as we speak. So just a view of my life. This is how I spend my life when it comes to Wi-Fi and security. I do the troughs and the highs and the lows, basically going from vulnerability to vulnerability, patches, fixes, and then somewhere in between here, we try to do some really cool innovation, specifically in standards organizations, Wi-Fi Alliance, what have you, and then also internal within Cisco. So it's actually pretty dynamic. I do enjoy it. It's one of those cool things that I get to do as another role as my day job at Cisco. So here's my big capstone. WPA3, for those that haven't seen it, is now mandatory as of July 1st, 2020. I threw up the Star Trek image because, yes, this was a 5-year mission. We have been working on WPA3 probably for 7+ years, but you know, it really kind of formulated about 5 years ago, and now it's mandatory moving forward for any brand new certifications coming out of the Wi-Fi Alliance. So this is kind of our baseline now. Again, it's a drastic change from where we used to be, and we've done a couple things, and I'll get into that in a second. My also view of the road to WPA3, we've got the IETF that feeds in, the IEEE that feeds in, and then I'm actually the green robot and the Rock'em Sock'em robot as a chair of a TG. I tend to get punched around a lot, but the whole thing is we try to bring everybody together, compromise, and get something useful move forward for basically the community, end users, installers, what have you, in the Wi-Fi community. Any questions so far? No? Okay. Just want to make sure we're tracking. So this is our program history from what we do in the Wi-Fi Alliance and where I exist. The reason why I bring this up is if you look at some of the dates, there wasn't a lot of activity around security for the last, I'd say, you know, since WPA2 came out. So that was in 2004. Before crack came out, it was kind of stagnant. And we've had a lot of accelerated activity in the last few years, which I'm not sure if everybody's aware. We've had continuous development on security since we launched WPA3 in 2018. For those of you that don't know, we actually are here. We had a feature release, right? We had some new features come out in December of 2019, and we're following that up from an industry perspective with some additional features in December 2020. Is everybody familiar with the fact that WPA3 isn't like a stagnant program like WPA2 was? Okay. Has anybody seen, I'm sorry, go ahead, was there a question?
No, I'm just looking at this. It looks like there's 2018, 2019, 2020. So it's a lot like the Windows 10 approach to operating systems. There's no more Windows. It's all just feature releases.
It's a really great question. So it depends. What we did was when we came up with WPA3, the branding changed. It was we looked at the significant changes we made. I mean, this could have easily just been called like WPA2 and just added features in there. What we did was we looked at the delta between how much we were adding and what we were fundamentally changing. So if it's just incremental changes, right, where we're just adding certain things to provide an overarching better product, better security mechanisms, we stay within what we call a hero brand. It's when we make some major changes, some monumental changes to what's going on, that you would see something change. Like somewhere down the road, you could see a WPA4 coming out, right? Does it make sense, Sam?
Yeah, it does. Thank you.
Okay. So now on to my favorite controversial topic. Open networks get an upgrade. Anybody following basically enhanced open OWE? Awesome. Has anybody deployed it? Okay. No problem. We'll get there. So Enhanced open, really the problem we're trying to solve, right? The reason why it's not classified under WPA3, the security brand, and it's its own brand, hero brand, which is enhanced open, is because we're preventing passive eavesdropping, right? I mean, that's really the only thing we declared with it. It's similar to open, but we're encrypting the traffic, right? So it's unauthenticated encryption. So it's privacy, not necessarily falling into the overarching security domain. So, you know, there are things that we absolutely don't claim, right? We're not saying this is going to solve our any man in the middle problems, right? It's not authenticated. So it's just so that we stop transmitting packets over the RF in the clear, right? So once we put those guardrails up, you know, there was a lot of debate in the community, and it was deemed to say, okay, hey, look, enhanced open is going to be the natural progressor, natural successor to open networks. And we'll get into where that goes in a few minutes. But for those that wanted to geek out, I threw in some packet captures. And again, the slides will be available. Everybody don't squint. There's a lot of information I tried to put on that. But again, you've got the pairwise cipher. Again, we're doing AES, CCNP 128. Management frame protection is required in this. And also, you know, basically with that, we've got BIP. So again, OWE, the IETF protocol we're using is OWE. The brand name is enhanced open. So you may see it in a GUI, you know, either way. Now on to my classic enhanced open transition mode. I've also got a capture for this as well. One of the things that we wanted to do was find a smooth way to get rid of open networks. So this enhanced open transition mode basically states that any AP that gets certified for enhanced open, when an open SSID is created on that AP, you have to subsequently create a OWE SSID at the same time and link the two together. Make sense? Okay. Now, I will provide my disclaimer. Again, this is my Steve Orr hat from Cisco and just a Wi-Fi community person. Nothing ever good comes from creating transition modes. Just remember that. That is my mantra. Every time I create a transition mode, I create a security vulnerability waiting for somebody to tee me up and take a bat to me. So that's usually what ends up happening, right? So enhanced open transition mode, this is just a capture of when I create the open SSID inside the beacon frames, I'm actually sending information about the corresponding enhanced open SSID. We did this for a very specific reason, because current shipping client devices that aren't enhanced open certified may see an enhanced open SSID and pop up dialog boxes, UI boxes, asking for a password, a PSK. Some may look at it as .1x. So there's a bunch of varied ways previously deployed clients may react. So what we want to do is try to mitigate any of this pop-up. So what we do is, as I said, we pass the enhanced open SSID information in the open SSID beacon frames, and vice versa, right? So if in the enhanced open beacon frames, we also pass the open so that we know that they're corresponding to each other.
I have a question for you, Stephen.
Go ahead.
This is Lee here.
Yeah, go ahead, Lee.
Good, thanks. Do you consider this OWE maybe analogous to something, you know, throw the authentication part away, obviously, just from the encryption perspective, do you consider this in any way analogous to something like an environment running 802.1x, PEEP, you know? Again, you're not doing the authentication, but when you get to the encryption part, where you're not validating server certs and stuff like that, do you kind of see this as, you know, kind of equal security just from the encryption perspective, or not really?
Well, no, it's a good point. So I actually see this a little bit slightly different. I see this analogous to, so in a WPA, let's call it WPA2 pre-shared key network, right? If I hand everybody the same PSK, I post it on a wall, everybody can see it. It's really not security, right? I'm encrypting the data in transit, but anybody that has the PSK can pretty much decode everybody else's traffic, right? So with OWE, we actually have, we're somewhere between pre-shared key network and what you were describing with PEEP, right? With an authenticated method. Each person that gens up an enhanced open session, unicast session, has individual unique unicast session keys. So it's not like PSK networks where we're all sharing the same unicast cipher. suite or unicast cipher key. Each individual person is negotiating their own unicast cipher. So it's a little bit more secure that way. The only thing we open ourselves up to is, as I had said before, since it's unauthenticated, you're trusting that the AP that you're connecting to is a valid AP at that point. Does that make sense, Lee?
It does. Thank you.
Sure. And the cipher suite you use here, there, you know, again, Wi-Fi Alliance and what's in the spec, we only test with AES CCNP 128. There's no, you know, you can have other ciphers, you can have other Diffie-Hellman groups, but we only test, you know, again, we can't test every permutation combination. They just test the required ciphers. JD, I think you had a question.
Yeah, I did. Thanks. So we've got this transition mode for 2.4 and 5 gigahertz. What does this look like whenever we go into 6 gigahertz where OWE is required? And we know every client that hits 6 gigahertz will have OWE capability. You
guys are on it. So here's the cool thing. I actually have a slide on this later, but we'll jump into it now. So one of the things that you know, we all try to accomplish is in any new band, any new frequency that we're working on. I personally hate transition modes. Again, they're just a pain from a security perspective. So what we worked on with 6 gigahertz and the new Mac-5 programs, no transition modes. So everybody can cheer, yay, no transition modes. Since it's Greenfield Spectrum, we don't have to support legacy stuff. So like 6 gigahertz when it comes out, you know, Wi-Fi 6E, you should see WPA3 is the baseline. Now, here's the one caveat though, JD. We're trying to eliminate open networks. So if a band does not have a use case for an open network, they may not have to deploy or support, you know, enhanced open in that case, right? So it's going to be on a Mac-5 basis on determining whether they have an open use case, right? Like I can see things coming down the line, like if you're doing outdoor Wi-Fi, right? You may not have an open use case there, so that to force a vendor or a PHY maker to have to jam in an open network, or not open, but an enhanced open network when they clearly aren't going to be using it, may not make sense for them. Okay. All good, JD?
Well, yeah. So, but if we are in a 6 gigahertz environment and we've got 6 gigahertz clients, what does the beacons look like? I mean, I'm assuming at that point you don't have the open. You really don't have an open SSID. You don't have the hidden BSS for the OWE. It's just one network. Is that?
Yeah. So if I back up to this slide right here for you, JD, this is what it would look like in 6 gigahertz, enhanced open only mode. Okay. If they you know, if 6 gigahertz has an open use case, they can have deploy enhanced open, but it's enhanced open only, no transition mode. So it looked just like this, these beacon frames.
Perfect. Thank you.
Sure.
Even I have a random semi-related key question because
sure, go ahead.
With the exchanges here, because some of the attacks, and if you know, in years recent, have been around the group keys and shared keys. Have any changes been made? I don't consider that very, you know, much of a risk given the nature of that, because they're already trusted devices typically. But were any changes made to that in this framework?
Yeah. So one of the big things that we push is, and if you look at the slide right here, everything we do now mandates management frame protection or protected management frames. It is not optional to turn it off. In enhanced open only and in anything WPA3 only related, PMF has to be negotiated, right? Or PMF has to be required. So we're helping in that sense so that we're protecting all the management frames that are going on. So we're trying to safeguard against kind of building that castle, building those walls so that no one specific spot can be compromised or attacked.
So I've got a question if JD doesn't have anything else.
Okay.
So you said OWE not technically part of WPA3, right? At least that's what I understand. But we have multiple revisions of WPA3 that are coming year after year after some particular cadence. Any chance it will eventually become officially part of OW3, some revision?
You know, it's a good question, right? I mean, the brand. This is not something vendors control, right? So this is a branding exercise like any vendor manufacturer goes through. What they look at is, what's my brand for Wi-Fi protected access? Typically, my brand is authentication, whether it's a pre-shared key, a passphrase, or .1x, and then encryption. The one part that Enhanced Open or OWE doesn't have in that critical brand is the authentication piece. We're not taking away anything from it, but when they lined it up, they didn't want to, you know, kind of confuse potential end customers, end users, or deployers on what the actual brand for WPA3 is. We're trying to get more secure, which again, Enhanced Open does, just not conflate the use cases.
Understood. Thanks.
Sure. All right. So I'll jump forward a little bit. So what's the difference between WPA2, WPA3? Actually showing my age with the Schoolhouse Rock. But, you know, first of all, for everybody that's involved, if you look at the slides I had before, the packet captures, one of the hard things that most people look at and they're not aware of is there's no information element that designates WPA2 from WPA3, right? It's all just the RSNIE. But what defines a WPA3 connection is the combinations of AKM, cipher suites, and PMF. So that's how we actually brand it. That's how we actually look at it. Some of the other differentiators we have is WPA3 is really about continuous security development. So we've had these multiple iterations over 3 years, or the last three years. We're trying to keep it transparent to end users. So it's not like, hey, look, I want WPA3 with something specific. We just continually add features into the WPA3 certification tool set. The other cool thing that we did is we shifted gears from just interop to interop and conformance. So we try to detect bad things before they happen. So some of the things in crack, some of the things that came after, we actually already had tests for in certain cases. So we were already kind of a couple steps ahead in the certification process there. You know, from a PMF perspective, PMF used to start off as a separate program. It's now integrated. PMF is required to be either negotiated or set as required for anything involving WPA3. And one of our first flagship programs, Wi-Fi 6. Wi-Fi 6 was the first adopter. They actually set WPA3 as the baseline during their launch. A couple level sets on modes. Everybody talks about modes. There are a couple in WPA3, right? So there's WPA3 Personal, which has SAE transition mode. Again, SAE transition mode. You can have WPA2 PSK on the same BSS. We have WPA3 Enterprise. Enterprise only, we'll talk about in a minute. But then we have Enterprise Transition, which is basically if I have PMF set as capable on a link, anything that doesn't negotiate PMF that's using WPA Enterprise gets designated as WPA2 Enterprise. If it's set to capable and it negotiates PMF, we classify it as WPA3 Enterprise. It's a little fuzzy, but what we're trying to do is stay within that brand to say PMF is actually not an optional capability within the WPA3 brand. And then we've got WPA3 Enterprise 192-bit mode, which again is kind of a high security. We mandate the use of ETLS, very specific cipher suites. We make the transition to GCMP with AES 256. So again, and that's really a common cryptography baseline from the KDF selected to the unicast group ciphers, as well as coordinating on the TLS cipher suites across the board. So it is 100, and the reason why it's called 192 is it's 192 bits of consistent security everywhere up the stack on the RF layer.
Stephen, can I just confirm something with you? When the 192-bit, that's for both the encryption of the EPOL messages, the use for the data messages, unicast, and also for the broadcast data messages as well? Yes.
So it's when you look at if you want to read .11 in there, they basically specify just the .11 aspects of the KDFs and the encryption unicast and group encryption ciphers. What we also did in the Wi-Fi Alliance side is we pulled in on the TLS side. So for ETLS, we also make sure we're using the GCMP SHA-384 cipher suites along with ECDH and ECDSA.
Now, with those cipher suites, for the message integrity, is still using a 128-bit key that feeds into that?
No, actually, it's we're still using the 256 key that gets paired down and carved up. Yep.
Okay. Okay. Great. Lovely. Thank you for that clarification.
Sure.
Stephen, what do these new cipher suites mean for the customers for the backend authentication?
Right now, at most devices, and if you go into your web browser, right, most devices are running those TLS, ECDHE, ECDSA cipher suites. So basically, this is just a natural progression. If you look out just a little bit on where TLS 1.3 is, TLS 1.3, which I think some browsers are actually using today, they've actually gone and eliminated some of the less secure cipher suites, and they're pushing everything towards GCM, SHA-384, and AES 256 for encryption. So we were just a little bit ahead out in front of TLS 1.3. So from an industry perspective, the way I see it is, as TLS 1.3 becomes mainstream, we'll be doing less and less CCNP, CCM, CBC, and moving straight towards GCM. One of the benefits of GCM, you can parallelize the processing for the crypto, so you can actually scale to much higher data rates on unicast and multicast cipher suites than we could with CCM. So like if you look at other industry technologies like MACsec uses GCM. They can scale to 100 gig, 400 gig at line rate with using the same unicast ciphers.
Okay, sorry, I'm meant kind of more like from a radius perspective, whatever the authentication is for the enterprise component of it.
The authenticate, yeah. So the TLS cipher suite, you mean, correct?
Maybe more specifically, I'm going to zoom out, as Lee says. So what would a customer need to do with their radius server to enable this additional set of cipher suites? Yeah,
so in the radius server, you basically pick and make, well, depending upon the radius server, I can't say all radius servers do the same thing. You have to go into the radius server and make sure which cipher suites you want to enable, right? There's usually a pick list that you can go in and select them. Otherwise, as I call hope not being a strategy, you hope they only have a certain set of cipher suites that can be enabled. So it becomes a combination of the radius server and the supplicant. Make sense?
Yep.
Okay. Moving on. So again, quick packet captures. I just wanted to give everybody some insights into what WPA3 personal only looks like. Again, we've got AES CCNP for the pairwise cipher. Really what matters here is the fact that the AKM is SAE, and then management frame protection. Again, this is very key. It's set to required. There can be no combination of SAE and MFP not being required that will connect in a WPA3 network. They both have to be, they both have to exist. Transition mode, however, what you'll see is management frame, same thing, I can have multiple AKMs in transition mode, but what you'll see is management frame protection is capable. However, for a SAE station, it must negotiate PMF. So it again, doesn't have an option to connect to a transition mode network without PMF. If it does, we actually have a test in the test plan that says if I have an SAE station and it tries to connect and not negotiate PMF, it fails the test. Again, anytime you enable WPA2 PSK on an AP that's been certified, it must go into WPA3 transition mode. Again, we were trying to push the market and get everybody to adopt. Again, my mantra: nothing ever good comes from a transition mode. As the post-crack attacks, everybody targeted in on WPA3 transition mode with downgrade attacks. My response was, sure. I mean, we knew it was going to happen. The question was, this is the delicate balance of usability and security, right? And security is always the one that kind of gets put to the backside because people want to maximize usability, right? So again, we're trying to spur that transition. What always makes me chuckle is it's 2020. AP support multiple BSSs now. We should be able to just segment off the BSSs and not mix lower and higher security stuff. When we were talking before on WPA3 Enterprise 192, again, you can see that the group and pairwise ciphers are AES GCMP 256. The AKM is specifically using SHA-384, and the BIP is using AES GMAC 256. That's on the RF side. When a station makes a connection, it has to negotiate the correct TLS suites with the radius server. There's actually a check that is done by the controller for a radius attribute sent back from the radius server, that the radius server has to tell the controller or the AP what cipher suites were negotiated for TLS. So if I connect to my Enterprise 192 network with all the right .11 cipher suites, but I negotiate a different TLS cipher suite than what's required, I still don't have access to the network. The AP or controller should knock them off the network. So this is actually the first time we have a feedback loop between wireless encryption and what gets negotiated on the radius side from an EAP method perspective.
So if I understand correctly, this is really about ensuring that or limiting the capability of any type of downgrade attack.
Yes, this is a very specific, right, that, over-the-air encryption plus EAP method encryption, ensuring that it's consistent is first and foremost. If anything does not match, you are not allowed to connect to the network.
And that matching is done in the controller.
AP controller,
but the controller
plus
function.
The radius server, right? The radius server has to communicate back to the AP or the controller which cipher suites were negotiated, right? Because normally the AP or the controller is completely blind to the EAP process as it occurs, because it goes between the supplicant and the radius server. This is a way to give the controller or AP insight into what's being negotiated during that EAP process.
Excellent.
Stephen,
so,
and I'm not familiar with this. I don't dig into the packet level. If you're actually using encryption from the radius server, though, is that part of it not encrypted, and so the controller can read it?
Right. So basically, when you start that EAP method process, it's in an EAP frame, and typically AP's controllers don't get involved in the EAP exchange, so it happens at a different layer. So that's why most devices don't get involved. It's typically a supplicant and radius server negotiation.
Okay, but that part of it remains unencrypted, so that then the controller or AP can see what was negotiated. So
it depends. Like in a normal TLS session, right? In an EAP TLS session, basically you're going to start an encrypted session, which would be for the credential exchange, and then everything once it goes encrypted is transferred. Or the APs or controllers can't see it. They cannot, unless they do some kind of a TLS proxy, which is bad. But okay, they cannot see the encrypted traffic between the supplicant and the radius server. Any other questions?
Can we talk about MAC address changes before we run out of time?
Yeah. How much time do I have? I got 10 minutes, right? So give me 2 minutes. I'll get to the MAC address problems. Here's some things, though, I wanted to share with everybody. Very important. Wi-Fi Alliance has become very transparent with what we're doing with security. If you're interested in security and haven't checked out these links, I highly recommend you go there. We have a new security homepage. All of our tech specs are published, tech spec addendums, security considerations document. And as a community, we now have the ability to provide feedback into the Wi-Fi Alliance. So anybody can go out, read tech specs, read the stuff that's published, and there's the ability to submit feedback. So again, I highly encourage it. Real quick, so WPA3, what came out in 2019, those updates, we had two big things: fast BSS transition. Never before had we done fast transition across the board, so we actually consolidated a bunch of use cases and brought those under the WPA3 umbrella, as well as server cert validation. I think there was a discussion before on supplicants or clients validating server certs. It's actually a program now, so we actually there's a certification around doing it. Fast BSS transition. Let me get to the crux of it. One of the things that we did was we actually put an AKM preference order. So stations that comply with the fast BSS transition, if you're doing personal, basically the first thing, if you're trying to negotiate, should be FT authentication using SAE, then SAE, FT PSK, which is with SHA-256, PSK SHA-256, and then unfortunately PSK. And the same thing goes on enterprise. So we actually put some structure around how stations should connect in a preference order via ACAMs that are being advertised. Server cert validation. What we focused on here again is we wanted to look at the clients and make sure they weren't connecting to let's call it evil twin rogue radius servers or radius servers that didn't have a valid cert chain. So how do you do that? You know, it's anything that's doing EAP TLS, right? Or has a TLS certificate. So EAP TLS, EAP TLS, EAP, either one. So basically what we're doing is we're making sure that the supplicants can validate the certificate on the radius server, the server cert, before they join the network. Now, there's a couple interesting things about that. There's two policies that we have for server cert validation. There's what we call trust override disable. So there's a policy that the network operator can set. And if the operator sets that trust override is disabled, in that profile, the end user cannot accept accept certificates or decline certificates. It's actually hard coded inside the end client certificate. There is a user override that you can do, but again, that policy is still set by the network administrator. So in order to get through this, we had a couple different methods that we wanted to use and make sure that it wasn't like, you know, most people just click, say, okay, there's a server cert that popped up, I'm just gonna click and accept it. We wanted to take a little bit of that and give people some more opportunity to take a look at it. What's coming in 2020? This is a big set of features that we worked on. It's been a long year. So we've got some hardening that we did to SAE. This cool thing called transition disabled indication, beacon protection, operating channel validation, another new feature called AP validation in public networks, and then client privacy. I will get to client privacy. That way everybody can beat up on me, since I know it's been a hot topic for the last couple of days. Is everybody familiar with all these features? Or anybody, is this the first time people are hearing about them?
There's a few on here I'm not aware of.
Okay, so what I'll do is I'll go through real quick to get to the other piece. So SAE hashed element, this is just stuff that's going on 11 RevMD. So we're incorporating that in. It's just another way to harden the password element generation. Again, just following the standard as it's written. We also looked at other things that were going on around beacon protection and operating channel validation. Again, trying to harden every piece of the network so that you know, clients aren't responding to invalid beacon probes, responses, et cetera, as well as OCV not responding to rogue channel changes, right? These were all part of what caused crack in some of the other attacks. So we looked at that, we took a really hard look at that, and we tried to harden the entire, you know, process of getting on a network. Transition disable. Again, this is another interesting one where transition disable, we actually come out with a feature that allows us to tell stations, don't do transition modes. Disable the transition modes in your profile. So it's an actual interesting feature. We signal it and basically say, hey, if you're going to do WPA3 personal, don't downgrade, don't permit yourself to downgrade to WPA2. AP validation in public networks. This is another one where we got a lot of feedback about evil twins in public networks where, again, if you look at what we were doing with enhanced open, great feature, but again, we didn't solve the evil twin problem. So again, we looked at this and said, hey, look, what can we do to authenticate these APs so we know and can validate the APs we're connecting in? So the task group came up with SAE public key. And what we're doing is using a fingerprint and public-private key pairs to generate a password. That password is then used on the stations to validate the APs they're connecting to. So these are some of the things that will be coming out very soon. And then on to the most important part of our conversation today, client privacy. Really what kicked this all off was 11AQ, now part of 11 RevMD. Again, randomized MAC addresses. I've been around a long time, so I'm sure most of you are. Does anybody remember IPv6 privacy addresses? We've learned nothing as a community about the impact of randomizing addresses when it comes to security. So again, the intent is right in looking at how do we minimize, let's call it personally identifiable information being exposed from the clients. Absolutely agree, makes perfect sense. However, when you look at it, client privacy and NetOps, they are a very delicate balance. As Daryl was talking about, and I'm sure you all have asked questions at just about every vendor, what does this do to NetOps? And I will tell you, I don't think anybody has a great handle on the overarching impact that this is going to have. What we're trying to do is put some guardrails up on what will happen. And then we're looking out, trying to go, okay, so if everybody's following the same rules, now what do we have to do from the infrastructure side to catch up and retool, right? Because if you're using randomized MAC addresses, everybody uses MAC addresses for policy. They use MAC addresses for access lists on wireless. How is this going to impact us, tracking, et cetera? So I know that it's an important topic. I know everybody has questions. So do you want to fire them off, or do you want me to get through the randomized MAC address slides?
I'd like to know if we're going to see it from more than just Apple.
You know, it's a great question. I would say from it's pretty much unified from a lot of station vendors that they want to support randomized MAC addresses. Again, the hard part is, you know, again, if you've got a robust supplicant that has a user interface, it's pretty easy to say, hey, go disable this. If you get down into the IoT space where MAC address randomization could occur, that's a little more difficult because there's no user interface to disable it, right? And if you've got randomized MAC addresses per SSID, or what they did with IPv6, right, is certain OSs would generate a new MAC or new IPv6 address every 24 hours. And some of the operating systems preferred those randomized private IPv6 addresses over their valid v6 addresses. You know, infrastructure security becomes a challenge, right? So, you know, I think it's a multi-vendor approach or a multi-OS vendor approach that's taking a look at randomized MAC addresses. This is some of the structure that's trying to be put around it, right? That a station will construct a uniquely randomized MAC address per SSID unless the profile explicitly says it's got to use a globally unique address. Also during active scanning, and also any ANQP exchange while it's not associated to a BSS. So there's a lot of places that people are using MAC addresses for. The question really just becomes what's the domino effect that we're going to see. So on with the locally administered MAC address. So again, when we say MAC address randomization, it's not like I'm taking the global MAC addresses and just randomizing those and hoping I don't, you know, step on someone else's MAC address. There's a local administrator bit that you can set in the MAC address, and that bit gets set to 1. So the upside to that is when that bit gets set to 1 for the locally administered MAC addresses, there's a certain pattern, right, that gets followed. And it's really the end of the first octet becomes 26A and E. So while they're randomizing from a heuristic or, you know, looking at it, I may not be able to track the individual user, individual person, but I can tell who's using a randomized MAC address versus a global MAC address. Options to deal with random MAC addresses. Again, this isn't a, do they make sense? I'm more in the blocking and tackling mode. Like, hey, randomized MAC addresses, I understand the purpose, but we also can't throw out, you know, 15 plus years of wireless and infrastructure security in the enterprise based on this. So one of the obvious things is using an MDM to push policy to the client and having the clients disable the use of randomized MAC addresses. Now, the interesting thing is right now in today in most of the supplicants, it's hit and miss on who is enabled by default, who you have to enable. When this actual certification comes out, if they support it, randomized MAC addresses will be enabled by default. So in the IEEE, there's also a little, there's a policy in there that you can actually have the AP send a MAC address policy requiring stays to adhere to a certain MAC address policy. The question becomes, does the stay adhere to it, right? So that's the other piece. The stays at any point can decide not to adhere to the policy. We did some work though with ICE, just to roll through this quick. Because of that pattern, right, the 26A and E, we can actually look at the MAC address and then do some interesting things based on randomized MAC addresses and the policy that the network operator wants to set. So, you know, again, this is ICE. You can do whatever you'd like with it. In a sense, you can deny access with instructions and say, hey, have a pop-up box come up and say, hey, you're using a randomized MAC address, please disable that in order to connect to the network, and have some dynamic policies applied. So any questions on randomized MAC addresses? No? All right. I've got like 3 slides left, and I apologize. I know I'm pressed for time. So high level, we talked about this. What does 6 gigahertz, 60 gigahertz, and new MAC5 programs look like? WPA3 is the starting point, so excited about that. No transition modes, yay, transition modes are gone. And we finally put an end to weapon TKIP, retired. Thank you for stopping by, WEP, TKIP. You've done your job. It's time.
Yay.
It's time to say goodbye. So again, excited about this because 6 gigahertz is one of the first times, right, since we had the opportunity of 5 gigahertz to try to change things from the start. And security's being pretty proactive here and trying to do it. So my reach out to this group and kind of closing is 2020 and beyond. Everybody here is influential. What do we focus on? And I'm not saying just Cisco. What does industry focus on for security? My view right now is security is pretty obscure. My mother has no idea how she connects to a network, right? She just connects. I think she probably still running TKIP because that's what her service provider puts on the cable modem they drop off at her house. But there's no real UI UX experience for them to figure out. Okay, yes, I'm running WPA3, but what? What cipher suites did I negotiate? Am I more secure or less secure than I was before? What kind of crypto do we need to start focusing on it for the next 3 to 5 years? AES 128 CCMP, that's been since WPA2. Do we need to start looking at something else? And our focus has got to be 3 to 5 years. Crypto changes, security changes. It's got to continue because if it doesn't, it gets stale and gets broken. So as I said, I'd love to hear feedback from everybody. Again, whether it's in this forum, offline, please reach out. Would love to hear what the community has to say and some thoughts from people with feet on the street that actually live and breathe and do this every day. The feedback's valuable. Okay,
just in general, Stephen, how do you see wireless specific security as, what's its importance in the overall, I'm a wireless user. How much should be application security? How much should be the health of my device? Do we overemphasize Wi-Fi security when we should also be looking at other things? I know it's kind of a big question. We could talk about it for hours. I'm just wondering your quick take on that.
I'll give you my 30,000 foot view. As a member of the Wi-Fi Alliance, I have my Wi-Fi security hat is on, and we focus there. As a Cisco employee, my focus is overarching architectural security. So exactly what you addressed, right? Having Wi-Fi security is great. What am I doing at the application layer? What am I doing, above and beyond, depending upon what the customer calls for, right? Again, this is one of those where you got to listen to the customer, look at their use case. Is it just application session? What do we have that we need for security?